Let's talk about the arc length 7.4, and I will only talk about the arc length. Well, we define by looking at the graph of a function, some continuous function, and I want to measure the distance, let's say here, from A to B, and I only want to measure along the curve. So I want to find the length along the curve that we call little s, the arc length. And so by definition, so let f be continuous on some closed interval from A to B. Then the arc length of f from x equal to A to x equal to B is this guy, just the integral from A to B of the square root of 1 plus f prime of x, all to be squared dx. So that's what we'll use here, and talk about smooth curve. F is a smooth curve, and that's what we're saying when we talk about this function is continuous on this interval. And so these two concepts are the same. Let's look at a few problems in this section, and this is the only formula that you need to calculate the so-called arc length. Let's take number 3. I'm going to find the arc length of this function, y equal to 2/3 times x squared plus 1 to the 3/2 power on some interval from 0 to 1 when you look at the graph. So first we need the derivative, because this guy's the derivative there, so we find y prime, that's 2/3 times 3/2 times x squared plus 1 to the 3/2 minus 1, so that leaves us a 1/2 times the derivative on the inside, 2x. So y prime is 2x times x squared plus 1 to the 1/2 power. So the arc length is the integral from 0 to 1 of the square root of 1 plus that derivative squared. So we have 2x times x squared plus 1 to the 1/2 power, and we square that, dx on the outside. So s is the integral from 0 to 1 of the square root of 1 plus 4x squared times x squared plus 1 dx. We continue. The arc length is the integral from 0 to 1 of the square root of 1 plus 4x to the 4th plus 4x squared dx. Let's simplify that some more. This is the square root of 4x to the 4th plus 4x squared plus 1 dx. That's a perfect square trinomial. So this is the integral from 0 to 1 of the square root of 2x to be squared plus 1, all to be squared dx. This is the integral from 0 to 1 of just 2x squared plus 1 dx. Now we integrate that. Now we're ready. So we have 2/3 x to the third plus x evaluated from 0 to 1. And that gives us 2/3 plus 1. And we get 5/3. Consider number 5. So we have y equal to 2/3 x to the 3/2 plus 1, and the interval is going from 0 to 1 for that one as well. So we need its derivative. So 2/3 times 3/2 cancels out. We just have left x to the 3/2 minus 1. That's x to the 1 power. So the arc length is the integral from 0 to 1 of the square root of 1 plus x to the 1/2 power, all to be squared, dx. So we get the arc length is the integral from 0 to 1 of just the square root of 1 plus x dx. Here we use u du substitution. So let u equal to the 1 plus x. We just say x plus 1. Du is just dx. So the arc length, s, is equal to the integral from 0 to 1 of u to the 1/2 power du. We integrate that. S is equal to u to the 3/2 divided by 3/2. The x's is evaluated from 0 to 1. We'll go back and put that in there. So this is 2/3, and our u was x plus 1 raised to the 3/2 power. So we simplify that and indeed evaluate that from 0 to 1. So we have 2/3. We evaluate the x at 1. That gives us 2 to the 3/2. Then minus, evaluate the x at 0. So we get 1 to the 3/2 power. So we get 2/3 times that 2 to the 3/2. That's the same thing as 2 times the square root of 2. And then this minus 1. And that's the answer. That's number 5. Let's look at number 7. We may need some more space. Y is equal to 3/2 times x to the 2/3 on the interval from 1 to 8. So we need the derivative. So y prime, that's the 3/2 times the 2/3. So we get x to the 2/3 minus 1. So 2/3 minus 3/3 is just minus 1/3. So here we to the negative 1/3 power. So the arc length is the integral from 0, not 0, it's going from 1 to 8. to 8 of the square root of 1 plus x to the negative 1/3, all to be squared, dx. So the arc length is the integral from 1 to 8, the square root of 1 plus, this is 1 over x to the 2/3 dx. So s is equal to the integral from 1 of the square root
of, this is x to the 2/3 plus 1 all over x to the 2/3
dx, and all of that is under the radical, so let me make sure you see that. Better. Now let's keep working. S is equal to the integral from 1 to 8. Up top we have the square root of x to the 2/3 plus 1, and down below this is just x to the power dx. Okay, so now let's see what we have. Let u, just change the color, let u equal to the inside of the radical, x to the 2/3 plus 1. So du is 2/3 times x to the 2/3 minus 1. 2/3 minus 1, that's 2/3 minus 3 over 3, or negative 1/3 dx. That's a 3 up there. So let's simplify that. Equal sign. We simplify this, and I want to get the x to the 1/3 and dx by itself. Look what we have. Multiply 3/2 on both sides, so I have 3/2 du is equal to 1 over x to the 1/3 times dx. Wow. Well, that gives me this guy and that guy. So my 3/2 du is that. So I get s now is equal to, see I got to use that 3/2. I'm just going to put it out in the front. 3/2 times the integral. This radical here inside is u, so I get the square root of u du. Now the du times the 3/2 gives me this x to the 1/3 downstairs. There it is. And the dx right there. There it is. So I've represented everything now in terms of u du. And so we simplify this. Look, this is 3/2 times the integral of u to the 1/2 du. We integrate. So I get 3/2 times u to the, that's 1/2 plus 1, that's 3/2 divided by 3/2. We're evaluating this from 1 to 8. Now the 3/2 and up top and in the bottom, they cancel out. So I have u to the 3/2, u, which was this. So I get x to the 2/3 plus 1, that's to the 3/2 power. That's evaluated from 1 to 8. Good. Now we plug in x to equal to 8, and I will look at the 8 as 2 to the 3rd to help me out with the cancellation. So I have 2 to the 3rd raised to the 2/3 power plus 1. All that is raised to the 3/2 power. Now we evaluate this at the 1, so this is minus 1 plus 1 raised to the 3/2 power. So this gives me this first part, this 3 times the 2/3, the 3's cancel out, you have left 2 to the 2nd, so I get 4 raised to the 3/2, 4 plus 1 is 5. So this is 4 2 to the second is 4 plus 1, that's 5 to the 3/2 power there. Then minus 2 to the 3/2 power. So your answer, you can write that this is 5 times the square root of 5 minus 2 times the square root of 2. Okay. All right. Let's do one more. Number 9. This is y is equal to x to the 5th over 10 plus 1 all over 6 times x to the 3rd on the interval from 2 to 5. So we got to take this derivative. It's a lot here, so my writing will be small. So y is equal to x to the 5th over 10. Simplify this. This is 6 times x to the negative 3. And so this implies, if I take the derivative, this is 5 times x to the 4th all over 10 minus, because I'm bringing down the 3, minus 3 over 6 times x to the negative 3 minus 1. So that's negative 4. So now we simplify this. So this is x to the 4th all over 2 minus 1 over 2 times x to the 4th. Keep on simplifying. Y prime, our common denominator, is 2x to the 4th. So x to the 4th times x to the 4th is x to the 8th minus 1. So now for the arc length, it's the square root from the interval, from 2 to 5 of the square root of 1 plus that derivative there, which is x to the 8th minus 1 all over 2x to the 4th raised to the 2nd power dx. This is the integral. Let's simplify that. 2 to the 5th. We got the square root. It's pretty big. So 1 plus, we just FOIL the top. So this is x to the 16 minus 2x to the 8 plus 1 all over 4x. We're squaring everything here, right? So this is 4x to the 8 dx. Keep on simplifying. The integral from 2 to 5, the square root. I'm going to add these two fractions, add the 1 and add this guy together. So that 1 becomes 4x to the 8th divided by 4x to the 8th. So I get 4x to the 8 plus x to the 16th minus 2x to the 8th plus 1 all over 4x to the 8th dx. This is the integral from 2 to 5, the square root of x to the 16th plus 2x to the 8th plus 1. Now on the outside, you take the square root of that, we just get 2x to the 4th dx. Now this problem just works out itself if you do it right. This is a perfect square trinomial right there. So this is the integral from 2 to 5. This is the square root of x to the 8th plus 1 to be squared, and the square root of that all over 2x to the 4th dx. So now you can get rid of that radical. So s is equal to the integral from 2 to 5 of x to the 8 plus 1 divided by 2x to the 4th dx. Keep on simplifying that. This is the integral from 2 to 5. We divide x to the 8th by 2x to the 4th, so we get x to the 4th all over 2. And then this is plus 1/2 times x to the -4 dx. Now we integrate. This is x to the 5th all over 2 times 5 is 10. So minus is going to jump in there. This is the 1/2. You get x to the -5 plus 1. That's -3. All over the -3, or put the negative here. So we'll just say 3. This is evaluated from 2 to 5. This is x to the 5th all over 10 minus 1 all over 6 times x to the 3rd. Now look at this guy. You know, it's evaluated from 2 to 5. Look here at what you have there, and then look at the original problem. Now I could have easily just said to you that this problem has a certain function, has a certain name to it, so all you do is just change that sign from a plus sign to a negative sign and you get the result for the integration, but you would have not believed me. So now what we do is, let's finish that. I'll bring it here. Say C hatch. Put hatch there. So we evaluate this function result at 5. So we get 5 to the 5th all over 10 minus 1 over 6 times 5 to the 3rd power minus now 2 to the 5th all over 10 plus 1 over 6 times 2 to the 3rd. And just plug that in on your calculator, and I did that as well, and you get something like 309.3195 or 309.32. Okay. Well, that's that. Thank you.